Hello once again, this is another lecture for Integrated Math 2. I will be discussing the law of sines today. So enjoy, let's get started. So, the law of sines, and first of all I want to talk about the fact that we've been talking about right triangles pretty much exclusively. It's always been right triangles. But today, and really for the next few lectures, we'll be talking about different concepts that apply to all triangles. Alright, so what I'm going to do is I'm just going to draw what we would call an arbitrary triangle here. So this is specifically not going to be a right triangle. Okay, that looks pretty good. So I want to label the angles and sides of this triangle so we can refer to them. So let's call the angles A, B, and C, and then the sides A, B, and C. And notice side A is going to be opposite angle A, side B is opposite angle B, side C opposite angle C. Alright, so this is done intentionally because generally the relationship is going to be the length of the opposite side will be in a similar ratio as the angle. Okay, so for example, if angle B is the biggest angle of this triangle, then the side opposite that would be the longest side. Okay, and so if angle A was the smallest angle, then side A would be the shortest side. Okay, if that makes sense. That's just kind of a general idea for triangles. Alright, so today we're talking about the law. Gotta love it when it auto-completes things for you. We're talking about what we call the law of sines. Okay, actually I want to check something. Okay, so the law of sines says that the ratio to the length of a side to the sine of the opposite angle. Oh, why did you do that? Sine of A is going to be equal for all the sides and angles of any triangle. So again, this is not a right triangle, but the ratio of, in this case, the length of side length A over the sine of angle A, is going to be equal for all three such ratios. So that ratio is going to be equal to the ratio of the length of side length B to the sine of angle B. And that's also going to be equal to the length of side C over the sine of angle C. Okay. So eventually we'll be proving this probably next week. But for right now, I'm just introducing it. So notice on top they're all lowercase letters because we're using lowercase letters for the side lengths. The uppercase letters are representing the angles. Okay, so you can use this to do what we call solve triangles. All right, so if you're asked to solve a triangle, what that means is you need to find the measures of all the angles of that triangle, and then you need to find the lengths of all the sides. Of that triangle. Okay, so you're going to be given some of that information to start with. But to solve means you're going to find the missing information. So basically, if this triangle is solved, it means you know all three side lengths and you know all three angle measures. Okay, so the problems that you will see are going to be, I believe, fall into two categories. Okay, you might be given two angles and one side length. Okay, that's one possibility, and I would say that case is probably a little easier because if you're given two angles, it's really easy to find the third angle. So you really just need to find those two side lengths. You could also be given one angle. Actually, let me say it this way. You could also be given two side lengths and one angle that's not between those two side lengths. So I'm going to call it a non-included angle. There are ways to solve it if it is an included angle. From what if I remember correctly, we need to use a different property, though. We won't be able to use the law of sines, and so we'll be getting to that a little bit later. But for law of sines, that has to be a non-included angle. Okay, because if it's included, then you don't actually know any of the ratios for law of sines. Okay, so just as a quick aside here, if we have a triangle and say we know this is 2 and 5, and but say we know this included angle is 30 degrees, well, I don't actually know any combination of side and its opposite angle, okay? Because I don't know this side, so I could find the sine of 30 degrees, but I don't know this side. I don't know either of these angles here. If we call this ABC, I don't know angle B or angle C, so I can't actually write out any of the ratios that we need for the law of sines, because remember, I need to know, or at least be able to calculate the sine of an angle, which means I need to know an angle, and then I need to know its opposite side. So we don't have any of those three combinations for any of these angles. So for example, angle A I know, but I don't know the side. Angle B I don't know. Angle C I don't know. So I can't use the law of sines for this. Okay, so we'll be learning how to do that later. Alright, so these are the two cases you're going to have. I'm going to do an example. I did put on an assignment for this, for the law of sines, but it's not going to be due until next week. I wanted to get started with this today, but we're not really going to quite get to where I'm going to be comfortable that you guys will be able to do the assignment well. So I made the assignment due for next week, so that'll be due the 20th. So right now I'm going to go and pull up a problem on Khan Academy. So I'm going to hide the whiteboard for a second. So I do not know what problem is going to come up. We're just on Khan Academy on the problem set for solving triangles using the law of sines. Okay. Alright, so it says find the measure of angle B. So we're not actually solving it, we're just finding one of the missing pieces here. Okay. But how we would find angle B, looking at this problem, well, let's just do the problem and then. But notice we have two sides and a non-included angle. All right. So the angle is not included in the two sides. So we should be able to do this using the law of sines. All right. So let me go back to my whiteboard and I'll draw a little picture of this problem. So applying the law of sines is not actually too difficult. So actually doing this problem probably isn't going to take very long or be very complicated at all. But let's draw our picture. So we have this triangle A, B, C. Oops. Sorry about that, I'm getting a little confused here. So we know angle C is 73 degrees, and we know two of the sides are 11 and 12 units long. So 73 degrees, this is 11, this is 12. Okay. And we need to measure angle B. Okay, so I'm going to find measure angle B. Once we do that, I'll kind of explain how you can find the rest of the triangle to if you were asked to just solve this triangle. Because once we find measure angle B, it won't be too difficult. But so notice the information we have here. We have the measure of angle C, 73, and we also have the side length opposite. Okay, excuse me, and we know this would be side B because it's opposite angle B. So we know that, and this is what we're trying to find right here. So remember our law of sines says that A over the sine of angle A, and remember again your side and your angle have to be opposite each other, is going to be, that ratio is going to be equal for all of the equivalent or the same ratio for the rest of the sides and angles of that triangle. So this would be equal to the ratio of the length of side B to the sine of angle B. Okay, so we know 3 out of the 4 things in this equation here. So we know A, actually the way I labeled this we don't. Sorry, let me fix this. We're not going to use A and angle A, we're going to use C and angle C. Okay, but remember this still is going to be equivalent because it works for all 3 parts or all 3 sides of any triangle. Again, this does not have to be a right triangle. No, I want it to be a C. So, okay. So now this is what we want because we know the length of side C and we know angle C. Alright, so now let's put in the information we know. We know the length of side C is 12 units. Okay, because remember this is going to be C because it's opposite angle C. Right, and then angle C is 73 degrees, so this is going to be the sine of 73 degrees. And so this is going to be the ratio, equal to the ratio of side length B. So 11 is going to be the side length B because it is opposite angle B. And then, and that's going to be over the sine of angle B. Okay, and so angle B, that's what we're ultimately trying to find here. Okay, so this gives us an equation. The only thing we don't know is angle B. Okay, so we can use algebra, and I'll show you, this is probably going to be at least one part of this will be new to you, but we can find angle B. So this is going to involve taking inverse sine, which I will kind of give you a little bit of a reminder of what we do when we get to that. So what we want to do is first we want to get the sine of angle B, that part by itself. So I think the easiest way when you have a proportion like this, remember a proportion is just a statement that 2 different ratios are equal. Easiest way to kind of start is just to cross multiply. What this will do is it'll get rid of any fractions you have. So we do the bottom of the left times the top of the right. So that's going to be 11 times the sine of 73 degrees. And we're going to set that equal to the opposite. So then the top of the left times the bottom of the right. So that's going to be equal to 12 times the sine of angle B. All right. So notice the left side, this is all, the sine of 73 degrees is going to be a decimal. We don't necessarily know what it is, but we can just plug that into our calculator. So the left side is essentially a number at this point. Okay, but on the right side we have sine B, which is the part we want to get by itself. So what we want to get rid of is this 12. So this is 12 times the sine of B, so we do the opposite. We're going to divide both sides by 12. And then 12 divided by 12 is going to be 1. And then I'm going to flip this equation around. So it's going to be the sine of B is equal to 11 sine 73 degrees over 12. Okay, and I want to point out here, whenever you're going to be asked to find an approximation, something like sine of 73 degrees, you might be tempted to put this into your calculator at an earlier step and just whatever that approximation is, just plug it in. But when you do that, you're actually making your answer less accurate because you're approximating in an earlier step. Okay, whenever possible, you never want to approximate anything until the very end. Okay, so if you're asked to approximate it, that's fine. We will approximate at the end, but we don't want to approximate the sine of 73 degrees and round it to, like, say 2 digits, because then we're using a rounded value again later when we come up with our final answer. So we're actually making our final answer less accurate if we approximate this earlier. Okay, so that's why you always want to leave approximations and just do all your approximation out at the very end. Okay. Alright, so now we have the sine of angle B is equal to this right here, and again we could find out what this is, but we're going to do all that at the end. So now what we want to do is figure out, okay, what is the angle B? Alright, so we learned that not last week, I guess earlier this week, we learned about inverse trigonometric functions, and that basically what an inverse trigonometric function does is it takes the ratio and sends it back to the angle. Okay, so remember that basically our left side here, after we find the sine of B, this is going to be a ratio. So what we can do is we can take inverse sine of both sides. Okay, so this is an equation. So if both sides are equal, if I take the inverse sine of both sides, that should send both sides to the same angle. Okay, and so whenever you're taking the inverse sine of a sine function, basically this inverse sine and this sine, they cancel each other out. Okay, so what's going to be left is just the measure of angle B. Okay, if you think about it, once I take the sine of angle B, that's going to give me a ratio, right? It's going to give me the ratio that is the sine. And then if I take the inverse sine, that's just going to send me back to whatever angle I started with, okay, which in this case was angle B. So now we are ready to put this into our calculator. So if you were asked for an exact answer for this problem, this is what you would give. You would give B, measure of angle B, and really I probably should have had this in the whole thing, because this is really a measure of an angle, it's not the angle itself. But it's equal to the inverse sine of this quantity here, which is 11 times the sine of 73 degrees divided by 12. Okay, and so now to get an approximation, what we'll have to do is we'll have to plug this into our calculator. So now let's go back to Khan Academy now. Alright, so we're going to need to use our calculator because we're asked to approximate to the nearest degree. Which I have to say I would rather give a closer approximation. But we need to now put this into a calculator. So all we need to put in is inverse sine. And then it's going to be 11 times the sine of 73 degrees. And again, note that I am in degree mode. And then I need to divide that by 12. And then I need to do it in parentheses because I'm taking the inverse sine of that whole thing. Okay. So that should give me my answer. So I say equals. What happened here? Am I missing a parentheses? Okay, let's try it again. I must have messed this up. So inverse sine of 11 times sine of 73 in my parentheses divided by 12, and in the parentheses for my inverse sine equals, okay, there it gave us an angle, so it's going to be 61 to the nearest degree, so 61.2, so I round down, so it should be 61 degrees. So let's check it. And okay, we got it. Alright, so I think it's good that I definitely didn't put this due until next week, because let's go back to the whiteboard then, just to kind of review the steps we did here. So whenever you're finding an angle and you have something like this, like you're taking the sine, or it could be cosine or tangent of that angle. So what you're going to do is you're going to end up using the inverse trig functions to find that angle. Okay, so if this was, for example, tangent of B, you would do inverse tangent of both sides. Okay, and then you would have a measure of angle B, and over here you would have inverse tangent of, whatever was over there. Okay, so this is just the inverse sine is new here, and yeah, I think that's probably a pretty decent explanation. But again, you will have to use your inverse sine in situations like this when you need to find your angle. You will almost always need to use not just inverse sine, but one of your inverse trigonometric functions. Okay, and so we got a measure of angle B was approximately 61 degrees. That's very sloppy. And I just want to point out, going back to our original triangle here, if we put a 61 here, and again, it's an approximation, it's not exactly, but depending on how accurate you wanted it to be, you could go ahead and find angle A next, because remember, 73 plus 61 plus whatever you want to use for a variable here would have to be 180. So basically you could do 180 minus 73 minus 61, and that would give you angle A. And then once you have angle A, the last thing you would need to find to solve this triangle would be side A, and at that point you could use law of sines again, using either angle C or angle B. So you would set it up like this: A over the sine of angle A, which you can figure out easily once you find angle B. And then you could use either B or C. So let's say we use B. So you would just use law of sines again to find the final side right here. Okay, and when you're finding a side, it's actually a little bit easier because you don't have to use inverse trig functions. I would say finding angles is a little bit trickier because you have to use the inverse trig functions. But again, the overall idea today, we'll spend more time on this. So if you're getting a little bit lost in the details for today, don't freak out too much. Just try to understand the overall idea here of the law of sines, which is, again, this works for any triangle, and that these ratios are always going to be true. So the ratio of the side length over the sine of the opposite angle, that ratio is going to be equal for all three of those ratios. Okay. So basically, you could use whatever two you need to find what you're missing. Okay. That's going to be the end of the lecture for today. So have a great rest of your day. Thanks.